This is our ME 439 final project for Group 5. Rahul Mehta, Andrew Clapper, and Liam Duffy. We implemented an Etch-a-Sketch using the inverse kinematics. We wrote our own code for the inverse kinematics and implemented this in ROS. And we're using rotary encoders as the knobs you would use in the Etch-a-Sketch. We also have a function, which I'll demonstrate right now, where if I push this button, the arm will move in towards the board, so you can pull off the board and write. So there you go. Now it's in ready position. We've got it on the board. And now as we turn these knobs, it's going to go ahead and draw. We can move it laterally, or we can move it vertically. And so I can do a little bit of a demonstration and write something. Well, that's the end of our range. But as you can see, you can write, and then if I wanted to, I could pull it back off of the board. Then I can move across. And here we're at the end of our range on the other side. So now if I move it back in towards the board, there we go. Write another message if I wanted to. And obviously, with any implementation, as you get further towards the endpoints, it's not going to be quite as accurate with the drawing. So you can see it shaking a little bit as it goes up and down. We like to pretend like that's a feature. So there you go. You can see that you can use the robot arm and the inverse kinematics in order to move across the board. And the rotary encoders, you can control in this case, the Z and the Y direction, just like you would if you had an Etch-a-Sketch in front of you.
And we also have it updating. Liam, if you turn the potentiometers, there's a ROS node that's listening to a bunch of different publishers, so it's taking all of the angle measurements and the pulse widths and the current coordinate, and it's putting it on